So good afternoon, ladies and gentlemen. I'm Pierre Souchet. I'm completely jet-lagged. That's the first time I do speak in English. So pardon my French. But I hope you'll enjoy the talk. So about me, I'm Pierre Souchet. I'm working for 3 years at Criteo. I first started as a kind of software architect. Then I did infrastructure, managing more than 15,000 bare metal machines. And now I just created a discovery team. The goal of the discovery team is to operate Consul, to create SDKs for all of our applications to interoperate nicely with discovery. And of course, to provide all the services you expect from Consul, including DNS and so on. In order to do that, we had to create several patches to Consul. I just learned that I was the first external contributor to Consul, so, but more globally, we really need to optimize the Consul for specific workload, and it's very interesting because discovery is all about naming things and invalidating cache, and everything knows it's the hard part of computing. So it's a very interesting challenge. So just a few words about Criteo. Criteo used to be a small French startup that was introduced and is now listed at NASDAQ. It's pretty big. It's in the advertisement business. So, and we have also offices in Paris, but also in Palo Alto, as well as Ann Arbor. And we are recruiting, so if you want to join us, give me a call. So we have around 800 employees in the R&D, and around a bit more than 2,050 or 700 employees globally. So we are present on all parts of the world. A little bit more about Criteo infrastructure. It's a pretty big infrastructure. It was initially a Windows shop. So there are lots of Windows bare metal machines. Globally, we have around 25 on-premise nodes in 8 data centers just for the production. We also have 2 data centers in pre-production. And around 50% of the nodes are running Windows. And the other one are mostly running Linux. We have a huge Hadoop cluster. We are performing lots of machine learning. We are using Kafka very heavily, and we also have a Mesos cluster. So it's similar in terms of features with Nomad for, we are currently moving away from our bare metal infrastructure in order to go to containers. And I'll dig into that during the presentation. And of course, we've got Consul everywhere. All the machines within Criteo are running Consul agents. So that's an interesting challenge because of the scalability of the whole infrastructure. So during this presentation, I'm going to talk about how we went from physical data center, physical bare metal machines, up to on how we want to go to containers using service mesh. And if you heard about service mesh during those talks, you probably have seen Paul Bank's presentation or Baptiste's presentation from HAproxy. We definitely want to go this path, and I'm going to explain why and how. And since we are already using service mesh within Criteo for a few years, I'm going to explain how we went from classical architecture up to service mesh. Do any of you in the room know exactly what is service mesh? So, basically, and you see how good I am at drawing pictures. On the left side of this draws, you'll see a classical load balancing architecture. So your application is going to talk to another service using a load balancer. And on the right side, that's the path we want to achieve, meaning service mesh, which is the application is directly connecting to the other services. So in order to explain the path we took, I'm going to take a very simple example of an app that could run at Criteo. Actually, we've got very similar kind of applications like that. So this kind of applications may have to handle more than 2.5 million requests per second, for instance, globally. So it's pretty big. So this application is going to be very easy. It's an application that displays banners. So the user is on the internet, is going through a farm of load balancers, for instance, using F5 or HAproxy, whatever you want. And then you've got my app. Well, in order to work, my app requires services. So you've got metrics, Grafana, Prometheus, whatever you want. You've got Memcache, because we've got lots of users. You've got SQL servers. You've got Kafka, and so on, and so on. And you've got microservices. Actually, Criteo took the path of microservices several years ago. Well, if you think about microservices, you often think about containers or small applications. Actually, the microservices we are using at Criteo for a long time are not micro. They are microservices because they are doing one single thing. For instance, tell me what is the preferred color of this user. Tell me whenever I have to display a banner for this user, and so on and so on. So it's kind of Unix tool doing one thing. But there are several of these, and those applications are huge. I mean, they are talking a full bare metal machine, taking lots of CPUs, are very optimized for what they are doing. So those are microservices. Why did we go to this path? Simply because those microservices are used by lots of applications because we've got my app, but we've got 10 apps like this. And all of them need to know what is this user. So we separated into several teams each microservice, and we are able to scale those services by adding new machines, for instance, on bare metal host, doesn't matter. So we are able to scale every part of our infrastructure this way. And it used to work well. The other thing to take into account is latency. In advertisement business, it's very important to have a good latency because there's a kind of auction system. And if you're too late, you're out of business. I mean, even if you say, oh yeah, I'm gonna answer to this advertisement, the auction system won't take your answer if you answer too late. So it's very important. It's a part of the business. It's not only QS, it's really part of the business. So we are gonna do this application with a traditional model, which is I'm gonna use a load balancer. I'm gonna use HAproxy because I love this product, so let's use it. And my application is gonna call the microservice using this load balancer. Well, with the scalability of Criteo, our microservice instance, which is a huge machine, you've got 500 of those. So it's pretty big. And you've got lots of those services everywhere within the company. So, but it might work. So this is the bandwidth of one of our microservices. So as you can see, we have very, very good engineers working well, doing async IO, stuff like that. And they are working very hard for their microservices to be very efficient. So those microservices, it's a real graph I took last week. So this microservices is getting very, very high in terms of bandwidth. Another issue is by adding our load balancer, our latency did increase a bit. And it's a problem for the business. When you have to answer into 20 milliseconds, every millisecond counts. So let's do some math. In one single of our data center, we've got something like more than 2,000 servers. And given the bandwidth I showed you previously, let's say we can put 10 targets per load balancer when it has a peak. So can anyone, because I'm dumb in math? Maybe someone? Okay. So the answer is far too much. Far too much because it costs a lot to add all those load balancers. If you have to add more than 200 servers only to load balance your systems, it's going to be complicated. Especially if you are using F5 or stuff like that, it's going to cost a lot of network dollars. And everybody knows that network dollars are very, very expensive. So we have lots of good engineers, so we have to find a way to avoid paying this infrastructure, this cost in every of our data centers. So what we did long time ago, when I say this, it's something like 6 or 7 years ago, we did client-side load balancing. So maybe some of you know Finagle or this kind of things. So we did implement our own load balancing mechanism, so a service mesh, which is implemented in API. So we've got libraries. We wrote one library for our C# implementation. We wrote libraries for JVM, Scala, and we've got the best of all the worlds, meaning we've got very, very good performance. We don't need all those intermediary machines, and we've got less latency. So it's really, really, really great. It was a great idea. So here is now our application. My app is using the CSLB API and discussing directly with every of the microservices. There's a drawback, however. For those having heard the presentation from Baptiste from HAproxy, he told us, don't do that. And he's right. Because it's very hard to get it right. Very, very hard. Only the CSLB code in our different libraries is more than 10 kilo lines of very, very complex code. Every time you are moving something within this particular code, it's difficult. You really have to get all the implications it's gonna do. If you want a new feature, you want TLS, for instance, well, that's very difficult because we oversimplify the stuff, and having TLS right is very, very hard. Another issue is everybody now wants to get rid of C# code and so on because Golang is cool, Rust is even cooler, Python. Everybody wants to use the right language for the task, right? Okay, but how do we deal with this CSLB stuff? It means that for each of these languages, we have to bring all of our code to the new language. It's messy and it's very complicated. Now we have a discovery team, we are 4. So 4, if you want to port your CSLB code to Golang or Python or whatever, it's gonna be very difficult for us. So we're not dealing with that. We don't want to deal with that. Oops. Oh. There's another issue. In my first application, I told you, oh yeah, there's a load balancer and so on. That's great, but still, this load balancer has to reach my app. And my app has maybe 500 or 800 instances. So you have to do all the provisioning by yourself as well. So we did it as well, meaning that we did implement our own system based on Consul, which is watching all the changes into Consul in live, and which is provisioning F5 load balancers as well as HAproxy. But still, it is almost the same job as providing CSLB. It's lots of work, very difficult. On the scale we had to implement our own Consul template clone, for instance, in order to get the things done. Otherwise, it was taking all the bandwidth available on the server, just to watch all the changes in your infrastructure. We've got more than 1,300 different kind of services in a single data center. So it's creating lots of bandwidth usage. Another issue is, of course, for the load balancer, you have other issues to tackle, which are TLS, virtual domains, and so on. So there are lots of more features than CSLB. We did work a lot on this, and finally, we figured out how to do that. But it's a huge amount of work. It's a full team working during maybe 1 year and a half. So it's very, very hard. Why are we doing all of this? I mean, we used to work without Consul. We introduced Consul 3 years ago, but we did find a way to get the job done. We are using a kind of discovery mechanism, relying on a database or something like that, polling the stuff and so on. It did work. But why are we doing all of this? Simply because we want containers. Everybody wants containers. Containers are hype, they are cheap, they are scalable. They are also very hard. Why are they so hard? We'll see this a bit later. So containers give you scalability, quick scalability. I mean, you can easily create a new instance of your app. For instance, for bare metal provisioning, spawning a full instance of a machine running a specific service for us takes around 3 or 4 hours. It's a long time. I mean, you have to image a machine, create the thing. We are running Chef. So it takes a lot of time. So at that time, having database is not a big issue. I mean, you can poll your system every 20 minutes and say, okay, there's a new entry in the load balancer and so on, and you don't need Consul for that. But as soon as you introduce containers, then you have to be more reactive regarding your changes. And containers are great for microservices because as long as you want to scale horizontally one of your microservices, with containers, you can spawn in a few seconds a new instance of your service and be able to answer to more requests from the internet. So that's great. Another thing which is very difficult to do with bare metal machine is to collocate several services. Let's say you have a service taking some amount of CPU and some amount of memory. We could say bandwidth as well. Another service running less CPU and more memory. With containers, you can combine both to run on a single host. And that's where containers are really great. I mean, it's all about the money. So being able on a single machine to run 2 services running with different characteristics is great. And that's the goal of containers on microservices, being able to scale them individually. Okay, so 3 years ago, we did choose to first introduce Consul, and we also took the path of taking methods. So it's It's similar to Nomad. At that time, it was one of the nice way to deploy containers. Now there are several more alternatives, such as Kubernetes, of course, Nomad. So we had to first bridge Mesos to Consul. So here is an example of one service running. So on the right side of the image you see, you will see one instance which is running Linux in a container, and on the bottom, no, that's the opposite. On the top, it's a Windows machine, a bare metal Windows machine running Linux, Windows, and on the bottom, a Linux machine in a container. So for Consul, those instances are similar. Of course, you can see we put lots of metadata and so on, but for the old discovery mechanism, everything looks the same. I mean, whenever you are reaching an instance in a container on a bare metal machine, it's the same for the caller. So that's great. However, we've got an issue because, for instance, we are moving away from Windows. We are moving to Linux, but the runtime is different. And moreover, you don't want to use very, very large containers. You don't want to use a huge amount of memory on CPU. You want to have smaller instances to be able to scale it horizontally with a fine-grained fashion. So it means that what you want to put in your container mechanism, container system is smaller instances. The problem is, if you want to scale up the thing and being able to answer correctly to each request from the internet, then you have to to put less load on your containers because they will be able to answer less requests per second. So what we have then is huge machine being able to take twice or 3 times the loads of containers. So we want to be able to address that. So that's pretty cool because we added support for wait in Consul a few weeks ago. I think it's starting with 1 to 3 version of Consul. So it means that Consul has a full knowledge of whether this app should handle a huge load or a smaller load. So it's very useful because otherwise it's almost impossible to move away from bare metal machine to containers. Great. We've got a new wait attribute into services for Consul, so we want to use it. Great. So first you have to wait for your Consul pull request to have it accepted. Once you've done this, you have to modify your CSLB client-side load balancing libraries in order to take this into account. Modify the ULB. That's nice. Takes a huge amount of time. Is it worth the effort? I mean, we are working so much for a small feature, and I'm not even talking about security. If we want to move away from our bare metal infrastructure, protected infrastructure, we want to move to the cloud, we want to move to containers, we need to add TLS, for instance. Okay, white is one small thing. TLS is far, far harder to implement. So can we find something that will help us delivering more for this kind of all those changes? Of course, Connect is there. So Connect offers you the low latency, the white. You don't have CSLB code to write, and much more. The biggest important thing for us is we are on-premise shop, meaning that our machines are running in bare metal server just with network cards and so on. We are not using a software-defined networking mechanism such as Calico or whatever. We are not running Kubernetes. We are interested by running those stuff, but it has to be compatible with that. And the big advantage of Consul is it allows you to run those kind of workload. So it allows us to migrate from a pure bare metal infrastructure up to a new one with containers, with fancy stuff such as Kubernetes. So that's great. So that's a big advantage to Consul because you don't have to say, okay, my port is hard-coded and so on. Consul provides all of this. So it's compatible with whatever you want. So that's a great selling point for us. Another very cool feature of Connect is intentions. I've been working on a cloud provider for some time with lots of microservices. And it's almost impossible in the current world of microservices to have a graph of dependencies of services. That's a big deal because when you stop a service, who's going to be impacted? If you stop your microservice, another microservice might use it. Another microservices might use this service and so on and so on. And it's almost impossible for now, in most architecture, to get a full graph of what's going on. Intentions are, of course, good for security, but on the long term, it will allow as well to create a full graph of the dependency of your full data center or global architecture. So it's very, very good on the long term to be able to have strict ACL, being able to see the full picture of what is going on within your systems. Another cool feature regarding the Consul Connect feature is being able to switch from one implementation to the other. I mean, you've probably heard about the control plane, which is Consul, on the data plane. And the data plane is implemented now with a pure Consul proxy implementation, Envoy, and HAproxy from Baptiste. So you will have the choice to choose the better implementation for you. And it will work not only for HTTP services, but gRPC, pure TCP stuff. So that's really cool, because you might address most of your needs. So what we did is we tested a bit Consul Connect on our infrastructure. It was a quick test. We did test it only with the default Consul Connect managed proxy. Mostly because we are running Windows hosts. So having a sidecar was not very practical at that time. And we did not test it on the whole range of our services, but only on the PaaS, so Mesos services. Still, it's around 450 different kind of services. And it's around 10,000 different instances. So this is quick result. Please do not take this seriously. It's imagine a random app, and we did some basic tests. What we found out is, compared to a direct connection, the latency did increase because we worked hard, very, very hard to implement our direct connections on our own service mesh. So it's a bit less. You have to do a hop to the local host. Compared to a load balancing approach, it's faster, of course, latency. You have one hop less. And the throughput is a bit worse. But what's interesting is just a default implementation, which is not really recommended for your usage. But it shows you can have some benefits using it. And the big benefit is now we can use CSLB for all the languages we want. And in the era of containers, everybody wants to use the right language for the job. So people want to use Python. People want to use Go. People want to use C#, Scala, whatever. And they can use it almost for free. That's very interesting. So all of this make me think that the future implementation, future tests with Envoy and HAproxy will be probably far better than those results. And on the long term, you will be able to use it without paying the cost of writing CSLB code, CSLB or libraries and so on. So it's a real benefit for you because you will avoid having all those classical load balancer stages between your applications on the microservices. You will get good latency, good throughput, so it's going to be really, really good. Another point is you don't have some kind of SPOF, because single pot of failure, sorry. And you will be able to have a scalable infrastructure globally for your data center. So just to summarize, what Consul Connect and globally service mesh do add as a value, which is you have less machines, you don't have to pay the price for lots of stages of load balancers. You've got network independence, at least with Consul Connect. I've seen many presentations showing how Kubernetes can work with Consul Service Discovery. That's a great thing as well, meaning that from Kubernetes or whatever the path mechanism you choose, you can interact with Consul. So that's a very strong selling point as well. You've got very fast updates on provisioning, probably better performance than with a real load balancer. So all of this make me think that it's a kind of future for everybody. And the biggest selling point, the biggest issue for me with Kubernetes on this stuff is it's a local bubble, meaning that the services are within Kubernetes, but they cannot go outside. So that's the greatest selling point for me to Consul Connect. Thank you very much.